Not yet.
Was that practice?
That was my practice. Here we go. Ladies, math beings, gentlemen, anyone watching this perhaps in the distant future after some post-apocalyptic event, and maybe you find some hard drives stored on Google's servers for their YouTube page, and you want to find out how to solve a triangle that's not right, because in the post-apocalyptic world, maybe that's what you need to do to survive. And maybe that knowledge has long since been forgotten by mankind for generations. And slowly, you are building yourselves back up to a technological empire. Welcome. We're talking about the law of science today. Let's draw a triangle that's not right.
That's just not right.
That's not right. So this angle here is a not right angle, okay? So this angle here, not right angle. This angle here, not right angle. And as a matter of fact, let's label these. Let's label this A, B, and C, like so. So I'm going to derive this for us, actually. We'll call this derivation or discovery. I'll just say derive today. Let's see. This is little a, this is little b, and this is little c, which is, I have a hard time writing lowercase and uppercase c's on non-linear paper, right? You know, Euclidean geometry. You know what I'm saying. So what if I drop a height from C to little c? So if I drop a height, that means that's a right angle, right? And this unknown height, I don't know, let's just call it H for fun.
F is for fun.
F is for friends.
We do stuff together.
U is for you and me.
And it's for any time.
Anywhere at all. Down
Here in the deep blue sea.
here in the deep blue sea, yeah. So anyways, so guys, check this out. From A's perspective and B's perspective. Sneezes. I also sneeze. No, this was a scalene sneeze, actually. So, from A's perspective, within this right triangle, you know some trig ratios. All right? So, behold, what is a trig ratio that compares the height and this from A's perspective?
Opposite over sine.
Sine, right? Well done, sir. So I could say that sine of A is equal to H over B, right?
Yes.
And how about from B's perspective, what's a trig ratio that compares those two sides that I know? Or don't yet know? Opposite hypotenuse. Okay, so we're saying that sine of B is equal to H over A. Now watch this, my mathematical friends here. What if I multiply both sides by B? And over here I can multiply both sides by A.
When did you get rid of the A and the B?
Well, look at this. I've got two equations and a bunch of unknowns. I would get B sine A, I want to say alpha, I almost did, is equal to H. And over here I get A sine B is equal to H.
Oh,
so
I'm good.
what must be true? Not quite.
Would be
Right, I can substitute.
H equals A sine B.
If both of those are equal to H, then they're equal to each other. So I will have, what's this? A sine B is equal to B sine A. And suppose I just wanted to rearrange some stuff. Let's divide both sides by A. This is just rearrangement from this point on, but technically we've already found a relationship that will help us solve things. So I will end up with sine of B
And sine of A.
is equal to B sine A all over A. What's up?
I forgot to just now that they switched and scheduled me a game this afternoon.
That's what I
I
heard.
can't do the duty switch with you today.
Oh, okay.
So,
All right, well, we'll figure it out.
Okay.
It sounds like SAT prep has a lot of kids going to a baseball game today as well, so
Okay.
it might not be a problem.
All right. Thanks, man.
No problem. So, and then I'll divide both sides by B, and I'll end up with the relationship sine of B over little b is equal to sine of cap A over
Cap
little
A.
a. And there is a relationship for a non-right triangle comparing an angle and the side opposite, an angle and the side opposite. That's a little a, yeah. And it turns out similarly,
Looks like a fish.
if I ended up drawing a height from like this spot here or something like that, you could end up doing additional relationships, and we would actually find that sine of c over little c is also equal to those, which is craziness. Sine of cap c over little c. And this, my friends, is the law of sines. You must obey the law.
No, you don't. Freaking good luck.
Well, actually, yeah, the people watching this video are probably from some, anarchist society.
Do you have a video over 50 views?
I don't think so.
Over 2 views?
Oh, wait. Maybe. I don't know. Yeah. I think really the only people that watch these mostly are my students. Although I have had some views from, like, other parts of the country and stuff.
Korea?
South Korea?
I wish, actually.
North Korea.
Not to be prejudiced, but South Koreans are notoriously experts at StarCraft 2. Seriously. And they're also very good at math.
Very good.
South Korea, Finland. Yeah, they know what's up when it comes to math. So let's see. So this is the law of sines. So how does this help us? Well, as I said when I opened the video, it will help us solve triangles that are just oh so wrong. So let's draw a triangle here.
Batman.
So let's label some information here. So suppose this is a 104-degree angle. Suppose this is a, oh dear.
You should just
Now I have breaking the
Suppose
law,
this is
breaking
10.
the law.
freaking the law.
Suppose this is a, 32-degree angle. Oh man, I hope I don't set up oh boy.
Oh, buddy.
Walking fast.
Okay, and I'm going to make this like, maybe I'll make this 4. There we go. So my goal is to solve, actually wait, no, you don't know that.
The answer's 4.
No, it probably won't be. My bad. So here we go. Here's some information. I can even label some of this stuff if I want. This could be A, this could be A. Sorry, I just called both of those A's. There's B. I don't know. Here's a little B. So what I want to do is let's find all of the information that I can.
Okay, go.
So I know 3 facts about this triangle. There are 3 other facts that I don't know. I'm missing 1 angle and I'm missing 2 sides. Question, how could I find the angle? The angle's the easy one. Angle B is going to equal 180 minus
They all have to equal
A plus C, right? So that's
Or
going
you
to
could just-
equal,
Or you could add up the 2 angles and then
yeah.
find the difference.
So that's 136. And so 180 minus that is going to be, I always mess this up, 44, is it?
Yeah.
So there's angle B. All right, funsies. Now, how do I find, well actually, which side can I find? You can only find them in a certain order.
Wait, what are we looking for?
Every other piece of information. I'm looking for B, A, and B. I just found
opposite.
B. So how could I find, say, this A here?
Opposite
Okay.
over.
Adjacent over what?
Well,
I don't know.
I can't do my regular trig ratios because those only work in right angles.
Would you find sine big C over?
Yeah, sure, let's do that. In fact, and actually also with these ratios, their reciprocals also hold true. So this is what I'm going to do. I'm going to plug in A over sine A is going to equal C over sine C. That's what I'm going to plug it in for and solve. Right, so I'm comparing, I've got these two and these two. I'm looking for one of those, so that's what I'm plugging in and trying to find. So little a is still unknown to us over sine of 32 is going to equal 10 over sine of 104. Question, sine of 104, is that positive or negative? Which quadrant is 104 in?
Who cares?
Second quadrant, sine is positive in that quadrant. What's the reference angle of 104?
It would be like
76. So sine of 104 happens to be the same as sine of 76. Okay, just throwing that out there. To solve for a, how could I get a by itself here? Multiply both sides by sine 32. So I'm going to get a equals, I like to write it this way, 10 times sine of 32 over sine of 104. And those are both technically in degrees. So a is about, let's see, if I could, I'd open up my... So let's see, we'll do 10 sine of 32. Make sure you're in radian mode. Divided by sine of 104. And I would get 5.4614. So there's little a. I just found a missing side in a non-right triangle. Yeah,
you win a gold star.
I do. Now, could I find a little b using Pythagorean theorem?
Nope, hold on.
No, why?
No.
It's an estimate.
No.
Because
What is that?
Pythagorean theorem only works in right triangles. So I can't find a little b using that. But what could I do to find b? The same thing, yeah. So let's see. I know this is 44 degrees. Right? Those are ugly fours. I don't know what happened
Wait,
there.
is that times sine of 32 over sine of
That's times, yeah. Yeah.
So
I just rearranged stuff.
So then it would be B over
Right, I'd
sine
co-
of 44 equals
Yeah.
5.
So I'll just do this. B over sine b. And I like to compare it to the pair that we already had. We had both C's. Because what if I messed up on A? I don't want to then relate it to the sine A or A over sine A, because if I messed up on A, I'm spreading my wrongness through the rest of the problem. So let's just compare it to
So then
these
if
guys.
you get B wrong and A was right,
Right. So I'd
Yeah.
rather relate it to C over sine C, just to preserve independence in the situation.
Do you always use sine?
Yep, this is the law of sine, so it's always sine, which is nice.
that's why the title's Law of Sine.
Settle down, friend. Settle down.
Law of Cosine.
So this is true for all triangles.
Come on, Jay. Box.
So let's plug this in. So this would be little b I don't yet know. Sine of angle b, that's sine of 44 degrees.
Is that sine? Does that equal sine, C over sine C?
Yep,
Is which one's the capital?
this one's the capital. The capitals are always the angles. So yeah, it's unfortunate. That's why sometimes they'll use alpha, beta, and Charlie. Nope. What's the Greek letter C called?
Charlie.
No, that's military acoustic sound alphabet, whatever it's called. The homoneutic alphabet. Nope. I don't know what I'm saying. I'm saying all the craziest words right now. This is great.
Foxtrot.
C. Why can't I think of C? The Greek letter C. What? Anyways, my mind is blank.
Um,
Oh, yes.
So to solve this, I would multiply both sides by sine of 44, and I'd get 10 times sine of 44 over sine of 104. Come on, Hotel Whiskey.
Why is yellow?
why is no?
Yankee is Y.
Yankee. And then it's
Let's see, so, gentlemen,
How dare they?
10 times sine of 44 divided by sine of 104, I get 7.159.
Ah! So you do 10 times sin of 44 divided by sin of 104?
You got it, dude.
Are you sure there is a C?
What do you mean? A Greek letter C? There's got to be.
Well, the next one after beta is gamma.
It might be gamma. And then delta,
Yep.
and then epsilon.
Yep.
Yeah, so it's got to be gamma. There you go.
Beta gamma.
Gamma, gamma, gamma.
Beta gamma.
Game gamers.
I want to teach my sons to call one of their grandmothers gamma.
Which one?
Well, they call my mother Mumu because that is the Finnish word for grandmother.
Really?
Momo?
No? Appa? Momo and Appa?
Yeah.
No? What? Aang was raised by weird animals?
Yeah, I guess. No, not Momo.
Anyways. So this is kind of cool stuff. You can find those ratios. And then one of the things you should always do is your smallest side opposite your smallest angle, friends?
Yes.
Right? 5.4 is the smallest side. It's opposite 32, which is the smallest angle. The largest side, 10, is opposite the largest angle. And the mediumest side is opposite the mediumest angle. So, in case you plugged it in wrong, that is how you check the reasonableness, the reasonability, the reasonableness of your answers. So let's see. Let's do one more kind of problem. I might even do it over here. One more kind of problem. Here we go. So let's solve the triangle.
Solve the triangle.
Solve the triangle. My name is Brian Waddy.
I don't want to look at the end of the video. It's supposed to say my name is Brian Waddy, and thank you for watching. Future
Follow what, folks?
viewers.
Oh, okay. Yeah, that's a good idea. So, let's see. So suppose, what if I knew all three sides of the triangle, but none of the angles? Suppose this was 2, 3, and... Actually, before I write that,
What?
could this be 1?
Yes.
No. Absolutely not.
Could you have a 1, 2, 3 triangle?
Yes.
Yes.
Yes? No.
Yes.
Think about this.
So
Ready?
the hypotenuse cannot be shorter than the legs. No.
Think about
no,
this.
Because
Here's 3,
the two legs
here's 1,
would have to be exactly
and here's 2. So imagine, here we go. Let's see if I can get some video of me doing goofiness.
It'd have to be exactly
Here we go. Oh man, my hair is so gross. Anyways, so imagine from elbow to elbow, I've got, man, I'm flexing now on the internet. This is weird.
future.
I'm not actually flexing. I'm just naturally like this.
naturally.
So suppose from elbow to elbow, that's my 3, and then this arm, right, forearm is 1, and this forearm is 2. What happens if they try to form a triangle and they reach each other? They would like barely touch, right? Is what would happen, right?
So blurry.
Yeah, it is blurry. Let's see if I can ramp. Let's see, focus.
Better.
There we go. So, right? So this is the idea that if 1 plus 2 equals 3, so they would barely touch, and that would not be a triangle. Right? Because it would just be a line.
Said the liar.
No? So, and imagine what if I had a longest side of 3, and then both other sides were 1. I'd have it like this. It'd be like,
You'd be like a T-Rex.
yeah, it'd be like, I can't make a triangle with a 1, 1, 3. It doesn't work. So it turns out that there's these inequality relationships that you have to be aware of between the sides of your triangles that the sum of two sides has to be greater than your third side in all cases. All right? So, blah, blah, blah.
Gotta be 30.
So the smallest, this has to be bigger than 1, and it has to be smaller than what number?
5.
It could be 4.
5.
It's got to be smaller than 5, right? Because imagine now the long side is 5, and then I've got 2 and 3, and they're like, bing, and like they barely reach, but it's no longer a triangle. It'd just be a straight line because 2 plus 3 is 5.
It's a square root.
So it's going to be less than 5. It's going to be greater than 1. Any number in between there would form a triangle. Okay? So that's a little thing for you to be aware of. So let's just say mine is 4. I don't know, 2, 3, 4. That could work because these add to 6. These add to 7. And oh wait, I just said 2 and 3 add to 6. That's not 2 and 3 add to 5. You know what I'm saying. So anyways, let's solve this triangle.
I don't even know how that happened.
That will be on the quiz, I guarantee.
What? T-Rex is going to be on the quiz?
Yeah. But no, if it, like, I have a question.
Yep.
And you have, like, when we just
Yeah.
I think I guarantee it's going to be on the quiz.
Is it now?
I think so. I am from the future, aren't I?
Interesting. So let's say this is our triangle. I know 3 facts about this triangle. I do not know any angles.
You don't.
You know what I just realized?
Can't do that.
The law of sines is not capable of solving this problem.
You broke the law.
I broke the law. This is a law of cosines problem. Man, I had that awesome explanation and everything. That's okay. Because the issue would be, well, I could have 3 ratios. I could have sine of A over 2 would equal sine of B over 3 would equal sine of C over 4, right? And any 2 of these that I compare wouldn't be enough information to solve it. So this one is unsolvable for the world of sines, but in a few days we'll learn law of cosines, and we'll be cool in even those situations. So, anyways, let's do one last one though, one that actually is solvable in the law of sines. So what do I want? I want 2 sides. What do I want? 2 sides and an angle. That's what I need. So let's make this 5. Let's make this 7. Now, if I knew this angle, don't write that down. Say that was like 12 degrees. I couldn't use law of sines to solve this either, because I need to know an angle opposite of one of those guys. So let's say I have 5, 7, and let's say this is, I don't know, 80 degrees or something like that. Okay? What is the next piece of information I could find? There's only one.
B.
You can find big B because it's opposite of that, and we have this pair that we already know. So I can't find this missing side A yet until I have further information, because I need an angle A, and to find angle A, I'd need angle B.
40.
So what's my setup? I'm going to say sine of B
Wait, you never
over
wrote the degree of
5.
B.
We don't know it. That's what we're looking for.
We're looking for B and A.
We're looking for everything. B, A, and little a.
Oh, I said my notes.
Sine of 80. Right. For me, when I'm looking for an angle, I'll put the signs on top. When I'm looking for a side, I'll put the little letters on top. That's what I end up doing, just so I don't have to reciprocate each time. And that's not 5, is it? Thanks. That's 7. So to solve for B, what would I do to both sides? Multiply by 5. And I would get sine of B equals 5/7 times sine of 80. Right? How do I get B by itself? It's tied up in a sine. Oh, there's no such thing as dividing by sine. Sinverse! So I'm sine inversing this whole thing over here. And I will get b is exactly that, the sine inverse of that. So what is b approximately? Let's see, I might be able to plug it in a calculator here. Flipping around, calculator time. Calculadora. So anyways, so I'm going to do second sine inverse. I was doing some, that was law of sines from earlier. There we go. Of what? I'm doing 5/7, was it?
Yes.
5/7 times sine of 80. And when I close this parentheses, that's closing the sine 80 parentheses. I have to double close to close the sine inverse parentheses. And I hit enter, and I get 44.7031.
Dora.
Calculadora. And now that I know this angle and this angle, I can now find angle A. How do I find angle A? Angle.
Sine of A.
Better yet. I can't use law of sines unless I also knew side A. How could I find...
Oh, it would just be B minus C, or B plus C.
Right? So that's 180 minus both of those added together. So 180 minus that plus 80. So I get 55.297 degrees is angle A. So now I'm missing one more component. I'm missing little a. And how could I find little a? Little Anthony.
Has actually good pizza.
A over sine of which angle? Guys?
I like his dad.
A over sine of which angle?
A.
55.
The 55.297 or whatever, right? Equals. And what should I compare it to? B's or C's? C's preferably because we were given the information about C. So is it going to be sine of C over 7? No, it's going to be, in this case, 7 over sine of 80. So the signs are always on the bottom or the signs are always on the top. It's never going to be mix and matched. So how do I solve for A? Yeah, so I'll have 7 times sine of 55.297 all over sine of 80. And you can rearrange that. Bless you. Bunch of different ways. So I'll do 7 times sine of second answer divided by sine of 80.
Pickles.
Nose pickles, yes. 5.844.
Pickles.
And is this in degrees?
Pickles.
No.
He's trying not to sneeze, I'm guessing.
Put your finger like this. Push against your face.
Look up to the light.
So guys, good news. We just found all missing information about this triangle. This is triangulation we're doing here. This is good stuff. All right? This is good stuff. So this is how you can find distances when you don't have right angles. You can do all sorts of crazy things. This is how little plumb bobs and surveyor dudes calculate things using trigonometry. Plumb bob. It's the name for the metal weight that hangs at the base of the tripod of their little little measuring tool, just to figure out where vertical is based on gravity. So anyways, so that is the law of sines. We're going to be doing some part A work after lunch. So I hope you enjoyed. Future viewers of the world, goodbye.